You've probably heard that sunlight takes about 8 minutes to get from the sun to the earth. It's one of those classic facts we all learn in school, a neat piece of cosmic trivia. But what if I told you that's just the final 8-minute sprint of a journey that began before human civilization? The light warming your face right now was born in an unimaginable furnace, and then had to fight its way through a chaotic maze for tens of thousands of years just to escape. This isn't a story about an 8-minute dash across space. This is the story of an ancient, epic voyage to bring light and life to our world. We tend to think of the sun as this constant, steady source of light, but the journey of that light is one of the most drawn-out, brutal stories in the solar system. To really get it, we need to follow a single particle of light, a photon, from the very moment of its creation, deep in the heart of our star. Our story starts in the most extreme place you can imagine, the core of the sun. Forget any kind of fire you've seen on Earth. This is a whole different level of power. We're talking temperatures around 15 million degrees Celsius, and pressure over 250 billion times that of our atmosphere. In that inferno, matter gets torn apart into a superheated plasma, which is just a chaotic soup of protons and electrons. This is where the sun's engine roars to life in a process called nuclear fusion. The insane pressure forces hydrogen protons to smash together, overcoming their natural urge to repel each other. Through a series of violent collisions, 4 hydrogen protons get fused into a single helium nucleus. But here's the trick. The new helium nucleus is a tiny bit less massive than the 4 original protons. That missing mass didn't just disappear. It was converted into a massive burst of pure energy, thanks to Einstein's famous EMC2 equation. And in that searing flash of creation, our hero is born, a photon. But this isn't some gentle particle of light. This newborn photon is a gamma ray, one of the most energetic forms of light there is. It's buzzing with power, born from the heart of a star. You'd think, being light, it would just zip out into space at, well, the speed of light. But its journey has barely begun, and its biggest challenge is just ahead. The moment our gamma-ray photon tries to leave home, it slams into a wall. Not a physical wall, but something way harder to get through. The incredible density of the sun itself. It has just entered the radiative zone, a layer so tightly packed with plasma that a photon's path is almost instantly blocked. Imagine trying to get through a crowd so thick you can only move a millimeter before bumping into someone. That's our photon's life now. A fraction of a second after it's born, it gets absorbed by an atom, which almost instantly spits out a new photon in a completely random direction. It could be forward, sideways, or even straight back toward the core it just left. This process is called a random walk, and it happens trillions upon trillions of times. It's like a chaotic cosmic pinball game where our photon is the ball, and the entire radiative zone is the machine. With each collision, the original powerful gamma ray is downgraded, losing a little energy. It becomes an X-ray, then ultraviolet light, and eventually the visible light we see. This torturous, zigzagging journey is what takes so long. Estimates vary, but scientists figure this random walk takes anywhere from 10,000 to 170,000 years, and maybe even longer, so the sunlight we're seeing today could have been generated back when mammoths were still roaming the Earth. After what feels like an eternity, our photon, now tamed into visible light, finally reaches the next layer, the convective zone. Here, things change completely. The plasma isn't as dense, but it's way more turbulent. The best way to picture the convective zone is as a giant boiling pot of soup. Hot blobs of plasma from below rise in massive columns, carrying our photon along for the ride. As these columns reach the top, they cool off and sink back down. Our photon is no longer fighting against single atoms. It's a passenger caught in these huge churning currents of hot gas. These convection cells are gigantic. Some are bigger than continents on Earth. Our photon gets swept up in these colossal plasma elevators on the last leg of its trip to the surface. It's a violent ride, but compared to the random walk it just endured, it's practically a superhighway. The journey through this final section of the Sun's interior is relatively fast, just a few months or so. Finally, after an odyssey lasting tens of thousands of years, our photon is on the verge of freedom. It's approaching the Sun's visible surface, the line between the star's interior and the vast emptiness of space. The surface of the Sun that we actually see is called the photosphere. Here, in a relatively thin layer, the plasma density finally drops enough for our photon to make a break for it. The endless game of absorption and re-emission is over. There are no more crowds, no more mazes. With one final push, the photon bursts free from the Sun's grasp and shoots into the vacuum of space. It zips through the Sun's wispy outer atmosphere, the chromosphere and the incredibly hot corona, but now it's traveling in a near-perfect straight line, totally unobstructed. Our photon, born so long ago in the core, is finally free. Trillions of other photons make this same escape every second, creating a constant flood of ancient energy that radiates out into the solar system. Our photon now has a destination, one that's 150 million kilometers away. This is the part of the story everyone knows. Traveling at the universe's ultimate speed limit, almost 300,000 kilometers per second, our photon starts its final sprint. That vast distance to Earth, which would take a commercial jet decades to fly, is covered in about 8 minutes and 20 seconds. This travel time means we never see the Sun as it is right now. We see it as it was over 8 minutes ago. If the Sun were to magically vanish, we'd still see it shining, feel its warmth, and orbit its phantom gravity for a full 8 minutes and 20 seconds before darkness hit. Every sunrise is literally a message from the past. Earth's orbit isn't a perfect circle, so this travel time varies a little, but after its multi-millennia confinement, what are a few seconds? Our photon is about to complete its mission. After a lonely trip through the cold vacuum of space, our photon reaches its final stop, Earth. But there's one last hurdle, our atmosphere. As it dives into the air, it starts interacting with nitrogen and oxygen molecules. This is where the magic of daylight happens. The atmosphere scatters shorter, higher energy wavelengths of light, like blue and violet, more easily than longer wavelengths like red and orange. This is why the sky is blue. It's the collective glow of countless blue photons being bounced around in every direction. And when the Sun is low on the horizon, its light passes through more atmosphere, scattering away most of the blue and leaving behind the brilliant reds and oranges of sunrise and sunset. Our photon, having made it through, finally ends its long journey. Maybe it strikes a leaf, where its energy is captured by chlorophyll to power photosynthesis, the process that makes the food we eat and the air we breathe. Or maybe it strikes your skin, its energy transferring as warmth. Or it could land on your retina, its epic journey ending in a flash of perception, letting you see the world. That single photon, born as a violent gamma ray so long ago, has delivered its energy and information from a star. The journey of a photon from the Sun's core to our planet is a breathtaking saga. It's a story born in the fury of a nuclear furnace, trapped in a seemingly endless plasma maze for tens of thousands of years, and then finally set free for a quick dash across the void. So, the next time you step outside and feel the sun's warmth on your face, take a second to think about what you're really feeling. You aren't just being touched by light that traveled for 8 minutes. You're experiencing ancient energy from a time long before any of us were here. You are witnessing the incredible finale of an epic journey that makes light, warmth, and life itself possible. If you enjoyed this cosmic journey into the life of a photon, be sure to subscribe and hit that notification bell for more stories that unravel the mysteries of our universe. Thanks for watching.